I'm Mike Maniscalco, CEO of QumulusAI.
Hi, I'm James Coomer. I'm Senior Vice President for Product at DDN. So we're here at the AI Factory on Wheels. We've put this together to bring together a whole pile of technologies that we've been developing with NVIDIA, with Supermicro, with vendors like yourselves in order to build an easier, simpler, faster, more efficient way of getting our customers from zero to a fully running AI factory. That's what this is all about. And as we look around the AI Factory on Wheels, you'll see all the pieces from implementation of different sort of pipelines, different customers, from video semantic search, life sciences, financial services. And we explain how we deploy in cloud environments. And then behind us, you'll see an Omniverse implementation where we're looking at how we simulate a robotic environment for manufacturing. And we'll also see a robot running in the corner of the AI Factory on Wheels.
It's impressive. I really didn't know what to expect when I showed up. I mean, I saw the renderings, but I didn't really pop the hood to look what was going to be underneath. And when I walked in my head, mentally, I was expecting to see a lot of racks and physical aspects. But then when I got here, everything was digitized. And I like that because, well, number one, the cost of putting a rack of GPUs and storage that everybody in the world wants right now in a trailer and locking it up is probably not the best way to use those in-demand compute GPUs.
And this is about how we tackle those technical challenges, really. I mean, for me anyway, I'm a product person, so I see everything as a technical challenge. But this really shows people visually and in real-world use cases how we do that. So it becomes so you could be, I don't know, a senator or just a CIO. You get it from this experience here. And a technology person would also get something out of this because they get to see in the pipelines exactly what's going on in terms of blueprints, in terms of the technologies, in terms of containers and NVIDIA microservices. So we kind of packed everything really well, I think, into this bus. And so that's half the challenge, right? And the next half of the challenge is how do we deploy it, and where do we go from here? Now people have understood it, they're excited, they can see the easy path to get into production. The next question is how do they get there?
I've heard the blueprints tossed around quite a bit recently, t-shirt sizing, and just making it easier because the technology right now is changing so fast. So how do you help the consumer understand what the best framework is for them to adopt today based on the current chipsets and architectures that are available, making it easier for them to make the decisions, but also making it easier for them to keep up with the pace of change is, I think, really helpful. On our side of things, one of the other challenges that we're seeing enterprises face, and especially the larger trading and inference providers, is keeping up with the pace of demand, keeping up with the pace of the chip cycles, and aligning that to how do we bring our capacity online on a reliable timeline. Because a lot of the decisions that were made 3 or 4 years ago on data center development and data center locations and data center designs focus on large 100+ megawatt campuses that were maybe based around Hopper, maybe based on Blackwell. But now we're looking at Vera Rubin. Now we're looking at the next generation of chips coming out that have very different requirements, and the data centers are having a hard time keeping up with that pace. So playing into the modular theme, we think there's a big opportunity to look at smaller, more modular, almost like designs for the physical deployments of the AI as well. So we can get our compute online a lot faster to align with the pace that AI is moving, to align with the pace that NVIDIA is moving, and get the compute in the hands of our customers a lot faster, so they get a lot more value out of that early on in the chip life cycle, rather than the tail end of the chip life cycle just before the next one's expecting to ship.
So one of the ways we help is by making all the mistakes first. But times are changing, right? And it seems like every year it goes more and more crazy in terms of the options and variety you have to build an efficient data platform. And most likely, especially in 2026, 2027, people are going to find a more heterogeneous GPU infrastructure is going to serve them best in terms of overall productivity per dollar, like value per dollar. But the question is, what is that ratio? How do I understand what ratio to use to outcompete or to out-research whatever competitors I've got? And that's really a challenge. And the first challenge is, how do I know? How do I find out what the combination of GPU types is for the best productivity? And the second question is, how do I get it? and that's the problem you solve.
Yeah, yeah, exactly.
To an AI strategy, they really have very little idea about how it's going to grow, which bit's going to be popular, where the new data is going to come from in the biggest volumes, which data is going to be accessed most. They don't know. Um, and so having that flexibility to basically just commit to a partnership and then have the flexibility to move with the business as the business evolves, because so unpredictable demand internally and technology being imposed upon you.
Yeah. And we even see that on the latency questions. What we're doing with Connected Nation and Moonshot and QumulusAI, and we're working with DDN AI to how we deploy these. They feel that is thinking about the future of inference and lower latency use cases or federated use cases. And right now, honestly, most of the customers aren't asking for we need compute in this specific region or we need compute within X thousand or X hundred kilometers of this zip code. Most customers right now are asking for we need compute yesterday and we
Yeah,
want it at a fair price and we
yeah,
need it in a trusted, reliable environment. That's what they want delivered to them. But if we can then modularize and deploy across a distributed geography of locations to bring that compute online faster, you fast forward a few years to the future of robotics and looking at the robot in the corner and start to think about, well, what are the low latency, ultra low latency use cases of the future we still don't understand. We have this network and we have this footprint of compute and start to solve some of those
yeah.
requirements. It's almost a hedge against the future.
No, you've hit on my favorite subject for 2026, I think, which is this inference optimization and how we reduce the latency for queries. So we've been talking about it for a while now, tokens per second and tokens per watt and time to first token, all this kind of stuff. Um, but essentially, we're at a point now where the technology has just been developed. So Dynamo version 1.0 has just been announced this week from NVIDIA. We've been working with it for about a year. And that's part, not everything, but part of the special sauce that can turn customers from like a $1 per productivity output to $10 or vice versa, depending on which way they go. So there's huge benefits to applying some of these new technologies to maximize the productivity right now, and it's changing every day. So we in this conference, we've been talking to NVIDIA, academic organizations, a whole myriad of organizations who are inputting into this new software environment, and it's complex. DDN, we've been working for 20 plus years in delivering high performance data solutions to customers around the world with the biggest data challenges. And the last 8 years of that has been dominated by AI and NVIDIA. And through that time, we saw these superpods being deployed. This is now 5, 6, 7 years ago. Massive superpods for the training of the original foundation models. DDN was right at the heart of that. And that was a massive, let's say, on-prem. It was like they were building the prem in the first place and then building everything at a dramatic scale. And of course, we've seen several waves since then. And now the wave is really for the Fortune 2000, 2000 plus enterprises to get value out of AI. They know it, we know it, and they've been experimenting, I think, broadly speaking, and in the lab. And this is the era of industrialization. And I think the almost the only path to rapid industrialization is via AI cloud vendors like yourselves who provide advanced services in conjunction with DDN to build these pipelines and stuff and basically get them up and running with NVIDIA software from NVIDIA, get them running with the correct reference architecture blueprints proven at NVIDIA, and we get them up and running in 100 times faster than they could do if they tried to build on-prem and experiment themselves and try to go from lab to production on their own.
And I like the speed aspect because a lot of times we lead with, well, customers need compute and they're having a hard time finding it at a decent price. But I think your point on speed is every minute, every day that you're not staying ahead of your competition in this space, you're losing traction. And then the
Yeah,
ones that are getting that traction are moving faster, are moving at the pace that makes it hard. And I actually think that's one of the things that NVIDIA has done really well is they started off with such a big
right,
lead, but
right.
then their lead is compounding faster than anybody else is
Yeah,
being able to catch up. And obviously there are plenty of people chasing them
yeah,
and they probably will find ways to compete in the future. But for the enterprises, you don't want to get left behind. If you can partner with good storage partners, good networking partners, good cloud services partners, good GPU partners like NVIDIA, and have them help you architect the solutions and avoid some of the pitfalls and get things online faster, but also keep those systems online and maintain them. I think that's another big part of maintaining these large clustered systems is it's complex and there are a lot of moving parts and pieces. I equated when I talk to neighbors, right? It's like you're redlining 1,000 Ferraris in a garage 24/7, 365. You're going to have maintenance. And it's going to be at that scale, continual maintenance, maintaining these systems, maintaining even the drives themselves. It's constant maintenance. So I think by partnering with all the ecosystem providers on the front end, but also partnering with somebody who can help you manage that system through its lifetime on the tail end is also a big selling point.
So absolutely, yeah. The pain in managing these things is not small. So if people want to get involved in that directly, I think it's we're not in that time anymore because this is no longer seen broadly as a cost center, right? It's seen as we need to get ahead of this in order to stay competitive in the market, and therefore it's how quickly can I do that? And by the way, I really don't need to get sidetracked by understanding how to deploy and manage and keep up 1,000 GPUs or more.
Yeah. And speed, trust, reliability, access, cost, like those are the things we really lean into. And then flexibility. It's like, hey, I have this specific need for this storage provider, for this networking architecture, for this kind of mix of certain types of GPUs. The cloud service providers can help you do that and give you a little more flexibility of how you put all those pieces together. Particularly, I think the neoclouds also cater to a little more customization for the enterprises.
Yes. Yeah.
Rather than if you were to go to one of hyperscalers and they say, well, these are our three flavors you have to choose from, and outside of that, we don't need to customize things all that much. Especially for the HPC consumers who are used to a little more customization. I think the neoclouds are high spin in my opinion.
Yeah, and we were mentioning it before we started videoing, is that this isn't the world of web services where you have a bunch of servers, you run a virtualization suite, and you deploy your models in virtual machines. It's like the opposite of that. So it is more like your 1,000 Ferraris. Everything's running at extreme output. Everything's kind of getting hot, if not in temperature-wise. They're always consuming all the memory bandwidth. They're pushing the networks. They're pushing the storage environments. They're pushing everything. And so that's when you need extremely strong reference architectures, blueprints, and proven technology and technology combination in order to keep that thing stable and productive.